Hello and welcome to this new DIY Engineers video. In this video I show you my latest and newest project, a smart multi-picture frame with video capability that has a motion sensor to know when to display the images and videos, and also a camera for facial recognition to show the right images depending on the user. Here you can see me showing pictures of a specific soccer player, and as soon as the camera detects it, it knows that that user is in its database and displays the pictures and videos that I stored on file for this user. So continue watching for more details on how I made this project. We'll need a Raspberry Pi with camera, we'll need a motion sensor, we'll need wood for the front cover as well as the outer frame of our total picture frame, we'll need a TV or screen, and we'll need tools such as a miter saw for cutting and a laser cutter for the front frame. So this is the TV or screen that I'm going to be using for this project, obviously without the stand here at the bottom. So my TV is a 24-inch TV, exactly is 23.6 inches or 600 millimeters. It has a height, the screen has a height of 11.5 inches or 292 millimeters and a width of 20.5 inches or 521 millimeters. The pixels are 1280 pixels by 720. And so if I divide the width and height of the pixels by millimeters, we get that is 2.46 pixels by millimeter. So this drawing shows the exact location in millimeters relative to the screen of where I plan on placing each image within the frame. So you can see here in top left, the top left image will be 9.53 millimeters to the right of the top right corner, and it will be the same 9.53 millimeters from the top, and the rest of the dimensions show the same, right? This is the location of the image on the light blue, and the red shows the end of the screen. So it's just showing where I would want the images to show up physically in millimeters relative to the top left corner. I said that's where I'll measure everything, but and you can see every other placement. If I divide everything by the 2.46 pixels per millimeter that we talked about, you get this. And this is critical because it will be used on the Python code to tell it where to place each image. So it'll show the location and it'll show the width and the height, right? So this one's 250 pixels wide by 375 tall. This one's the same height, right? 375, but the width is 562 and so on, right? We do that for all of them. Now it's important to know that when I make the frame or the top cover that covers the images, so we only see, the wood that'll be laser cut and that it covers well each image, is slightly smaller, the holes are slightly smaller than what the images were. So for example, here we see 95.6, this one was 101. So basically I have a margin of like 3 millimeters on each side to make sure that it's well covered and that I don't see black where it really should be an image. It's kind of like the equivalent of having a picture fall slightly within the frame. So we want to avoid that, and that's the rationale for having these be slightly smaller. So this picture you see here, this drawing, will be the drawing with the dimensions of what I plan on sending to the laser cutter, right? The red is basically the frame, it's everything that we're going to cut. You see the 6 openings, and then the openings here for the camera and the motion sensor. And so I designed this part on SolidWorks. You can use any other software, but this is just what I used. And you can see it has all the features. I made it of the right thickness, which is not necessarily relevant, but after this I went ahead and converted it into a 2D drawing that then simply gets saved as a DXF file. So I can do save, and then under save type I just need to pick DXF, which then will allow me to import it into Lightburn. And one thing that is important is that when I import the drawing, that I imported into the drawing with an aspect ratio of 1:1. So here you can see I picked 1:1 to ensure that the DXF file properly saved in the right size, so that it's properly imported into Lightburn. So now we go into Lightburn, and the first step is to import our DXF file. Then I'll go ahead and remove all the stuff that has nothing to do with what we want to laser cut. Then we'll go ahead and rotate it and put it in the place of the bed where we want to cut it. Then I'll reference my laser cutter instruction manual to see what they would recommend in terms of settings for basswood 3mm. So they say 150 divided by 60 to get into the right units for Lightburn, and 80%, so it's 2.5 millimeters per second at 80%. And that's for one pass. And again, the 150 was millimeters per minute. So then all you have to do is go into File and save as a G-code. So now I'm going to go ahead and with some scrap wood, cut a few circles to test to ensure that the sensor and the camera can fit properly in those circles before going ahead and cutting the big frame. So now let's check the fit. This is the camera, looks good. And this is the motion sensor, also looks good. And obviously the only thing I'm gonna have to do is I'm not gonna cut it with those lines that from the drawing that tell you where the center of the circle is. Those will be removed. So now I'm good to go and cut the main frame. Alright, so here's the piece after cutting. And so after pushing it, the piece came out just fine. You can see the front looks perfect. And I'll go ahead and start working on the rest of the frame. So I went to my local hardware store and I got some 4x1s and some 1/2 inch by 2 inch boards. Now to cut the frame, I line up the wood piece with the TV on one edge, set it on the other edge, mark the line, and then we'll cut. Now this is the current status. You can see we have the 2 horizontals cut, and I went ahead and for now, just for show, I put the laser cut piece and then the TV. You can see there's some space here. What I'm trying to get at is don't cut the next vertical pieces that go here based on the dimensions of the TV, because you need room at the top for the sensor and camera. So the next pieces will be cut based on the laser cut dimensions. So it will have to look roughly like this. I'll make a little bit more room because we don't want to press fit these pieces between the frame. So I'll leave like a millimeter or 2. But I'll go ahead now and measure the verticals. So now we'll cut the first vertical piece. So we'll measure the second vertical piece the same way as we did with the second horizontal, setting it flush with the other one, drawing the line, and now we cut. So after making all the cuts for our frame and kind of like putting it together, right now it's not fully assembled, like it's not attached yet, but you can see the laser cut frame inside there and you can kind of get an idea how it will come together. So we now start setting up the front of the frame. That makes it, makes it look nice. And I have to start making diagonal cuts for a frame. Start making the first one, then measure, make the second one. And we'll go ahead and make the initial cut for all the other diagonal pieces as well. Now when I align the 45-degree piece with the frame, this other end is pretty much flush. So I'll have to make sure to get the cut exactly and near the corner or as close as possible. Now I will not be changing this angle because I could set it on the other side also at the 45-degree, but the chances of getting exactly the same setting as what I have here, it's going to be pretty tough. So what I'll do is instead of placing the piece on the same orientation it was, I'll flip it 180 and be using the same cut but on the opposite side. So basically this was the first cut, flip it around, make the other cut here, and that'll give us one side and then the other side. And again, for this type of cut where it matters exactly where I make it, these clamps are super helpful. Now we measure the same way and make the remaining 3 cuts. Now all the pieces are cut. We have our frame, our 45-degree pieces, the laser cut piece. So now we're ready to assemble and then stain. So I got these brackets off of Amazon. Take a look. They'll have a good penetration relative to the thickness of the wood. So basically it'll be a little bit less than this since the bracket will be in between them, but I still think it'll be pretty good. I'm gonna go ahead and connect the corners using those. So now we have the assembled frame. I'll go ahead and overlay the 45-degree pieces that we just cut so we can have an idea of how they're going to be placed. And then we'll start by removing the first one and starting the gluing process. I apply small amounts of glue throughout the wood member, and then I spread them, always making sure to follow all safety precautions associated with the wood glue that you're using. So then I lay over the piece to start attaching it with the glue and repeat the process on the remaining sides. It's looking good. Now I start painting the front laser cut piece. I'll use some white acrylic paint, making sure to cover everything that will be visible. So this includes obviously the front, but there might be some edges on the inside of that thickness that you just want to make sure you get properly such that they're not visible from different angles. And then I'll start staining my main frame, again making sure to cover all surfaces that will be visible when anybody looks at the frame. So this is obviously the front, the outer sides, and some of the inner sides, specifically on the 45-degree cut pieces. And so this is what it looks like. Now all painted and kind of placed together by hand. And then I'm gonna secure the TV with brackets. Of course, just snugly, right, so it doesn't slide up and down. So this is the Raspberry Pi 5 case I recommend for this project. I like it for its GPIO access and camera access. So it comes with the tuck cover, the bottom portion of it for rubber feet, and a bunch of screws. All right, so step one, put the Raspberry Pi inside the case. Here you can see we have access to our USB-C power, the 2 HDMIs. We have our Ethernet ports, USB 3.0 and 2.0, and then super easy access at the top to our GPIO pins. There's plenty of opening for passive cooling. You could probably even slap a fan on top of there. So yep, I really like it. I mean, it's compact, and like I said, my favorite part is the easy access to the GPIO pins while being able to have a quick thing to attach a camera holder if you want to do any projects with camera. Here's the micro SD card slot. So I went ahead and made sure to remove the card while I was doing the work. Now I can go ahead and put it back. Okay, so here I'm starting with a fresh version of Pi OS on 64-bit with my Raspberry Pi 5, and this comes with Python 3.11. So first, as I started, I see here that there are updates that I can make, so I'm just gonna go ahead and make them all. Now let's go ahead and open the terminal, and we'll start by doing sudo apt-get update, making sure we have the latest packages, and then sudo apt-get upgrade. Okay. Now we'll make sure we have the virtual environment module installed, so sudo apt install python 3 venv. I misspelled install, so let's just try it again. So it didn't do anything because I already had it. It's important to make sure you do it if you don't have it. So then we make sure to install OpenCV, so sudo get install python 3 numpy. So it already came by default. And then same thing, but OpenCV. We tell them yes. All right, so now we'll start the steps to install dlib, which is required for the vision processing. So we'll do sudo apt-get install build essential c make yes, and sudo apt-get install libgtk-3-dev. Yep. And sudo apt-get install libboost all dev. Yes. Next, we'll go ahead and create the virtual environment. Python 3.11, and I'm calling that out specifically because I was having issues the way it was being created before, so I'm going to specify that space -m space _system site packages. This command basically makes sure that it uses the system-wide already installed packages, and it will also allow to have access to like the PyCamera 2 module, all the other stuff we just installed with sudo apt, etc. And we'll have a space which will specify the name, so we'll call it DIY ENG, and you can call yours whatever. And so run that. I missed the S after packages. Sorry, it looks like I'm missing entirely the virtual creation command, so this is VENV there. So it did a little something, thought about it, and then it returned this. So now we should be able to activate and enter the virtual environment. So for that we do source DIY _ENG, since that's the name of my virtual environment, and /bin/activate. And as you can see here, now we have this thing over here. It says DIY engineers, and then just followed by this. So now we're officially inside the virtual environment, and the new guidance is to now install all pip modules within the virtual environment. So all the subsequent pip installs, we're going to do it inside of this virtual environment. So we'll start with pip install rpi-lgpio. Okay. Then we'll do pip install -U pygame space -user. This one will be used to allow us to display the images at very specific locations in our screen. We'll do pip install media pipe. All right, then we do pip install scikit-image. All right, and now this next one can take a long time. I've seen it take 15 minutes or even up to 30 or more, but we'll see. I'll do pip install dlib. I'm just going to pause the video and come back when it's done. All right, finally finished installing. So the next step is to start Python. And then we'll do import dlib. And the whole point of this is to test that it was installed correctly. So when I hit enter, I don't get any sort of errors or anything, so it properly imported, so we're good. So we hit exit to exit out of Python. So next we can go ahead and do pip install face_recognition. All right, so now we have installed everything we needed, and we'll move to the next step. Now, before we do anything else, I'm going to show you the folder that I have created up and how I have it set up. So within HomePy, I created a projects folder, and then this is the project that we're going to be working on. So I called it frame. Within frame, we have 3 folders in the main Python file. We have face_recog. What this has is basically the pictures of the images we're going to recognize. So for the example, I have here soccer player, football player, depending where you're from, of Cristiano Ronaldo, and this will be the image that the Python code will be comparing against when presented with another image via the camera. So I'll display then another picture of Cristiano Ronaldo from my phone to the camera, and it will basically identify him as the match, and then it will continue with the code to display the pictures and videos that we want to display. So this is like the reference picture. Under images is the images we want to display. So I have here one as a black screen that we're going to use for part of this. The code, the users, right? As I showed before, under here, we have 3 users, 1, 2, and 3, and they have the picture that represents who they are. Here, if we identify user 2, which was Cristiano Ronaldo, it will then have these pictures for the frame, right? So bottom left, bottom mid, bottom right, top left, top mid, top right. Black screen, and then unknown user. I mean, you can set up whatever pictures you want here. I went ahead and set these. So unknown user is when it detects a face, it just couldn't match it to any other faces we stored under face recog. So the scenarios are: it detects a user and it knows who it is, it detects a user or a face and it doesn't know who it is, or it doesn't detect a face at all, meaning there was motion in the sensor but it didn't find a face. Then we'll go under videos, and same thing. And it's important to name them what I have here because the Python code will reference the name. So bottom underscore left, mid, right, top left, top right. And at the top middle, it'll just display the picture without video. So if I go to this one, if I go to another one, okay. So that's how I've set up this structure. Now let's just go ahead and for now run a test before we go over the code. So I would have to do, again, I'm within the virtual environment still. I do cd projects. Now this shows I'm inside projects. I do the same thing, frame, now inside the frame. And all I would have to do to run Python code will be to run that command, right, for main4. That will be Python main underscore 4.py. Now right now I have the camera looking at me, so it'll detect my face and show the images that I picked for user 1, which are pictures and videos of projects I've done. And I think on this one I set it to loop for 3 times. That's something you can change. So it does the last video, it holds for like 5 seconds and restarts again. So that was one iteration. This will be the second one. And then after finish, it'll do another one. The whole intent is like, I mean, how long would you like the screen to show the pictures and videos associated with what you picked? Just considering how long somebody might stand looking at the pictures in front of it, you might not want it to shut it off right away. And we'll fast forward after this. So now that it's finished, the screen goes black. What I'll do is I'll activate the motion sensor again, and instead of letting the camera see my face, I'll let the camera see Cristiano Ronaldo. So it displays the images, and it'll basically do the same thing. So we have the frame, everything set up. Let's open the command terminal and move to the next step. And so we can see the screen is black. Once I get in front of the motion sensor, it will see me. And once the camera detects my face, we'll go ahead and run the images and video for DIY engineers. So now that it's finished, I'll show the image of Cristiano Ronaldo. Alright, so that concludes the test. I really hope you liked the video. I'll start it again because I'm in front of the camera. But I hope you really liked the video. If you did, give us a thumbs up and subscribe. And see you in the next one.